Good morning, everyone. My name is Umang Saini. I am a product line manager with Juniper Networks. Joined with me today is Sujit Ghosh from our technical marketing team. Today, we have some very exciting news to share with you. We are launching today our brand new campus access switching product line, the EX4400 switches. These switches are truly born in the AI and cloud era, and they're designed from the ground up for being deployed and managed from the cloud. These are the industry's first truly cloud-native enterprise switches, providing agility and scale to our customers. These switches, they're designed to simplify our customers' operations and deliver best user experience using Mist AI technologies and the modest conversational interface that Sudhir and Bob talked about. These switches, if you take a look, we have taken great care to every little detail on getting these switches onboarded into the cloud. As simple as scanning a QR code on the switches to scan them and get them claimed in the Mist cloud, to getting them onboarded within a few minutes and configure the customer network, and then monitor them, troubleshoot if any problem arises, all from the Mist cloud from day one. Our focus has been capability, flexibility, and ease of use of these switches from the cloud. And we use and leverage the Mist AI technologies to do that. There are some key differentiating features that we offer with these switches, including hardware and software, but most importantly, standards-based microsegmentation that we'll be talking about more in the next few minutes, which leverage EVPN VXLAN capabilities of the switch to deliver granular and location-agnostic access control security policies in the customer network. And last but not least, we will also be talking about flow-based telemetry, where we can detect anomalies in the customer network by monitoring thousands and thousands of flows, customer traffic flows, going through the switches in real time, in hardware, and sending out IPFix alert messages in case there is any DDoS type of attack on the customer network. So the EX4400 switches truly offer a differentiated hardware and top-notch performance. So let me talk a little bit about some of the key benefits and use cases that we enable with these switches. So the EX4400 switches support EVPN VXLAN, which enable customers to deploy scalable and flexible standards-based EVPN VXLAN campus fabric all the way to the access network, access layer of the network. They can also use the switches to configure end-to-end line rate traffic encryption with MACsec AES-256. And we can also power digital buildings with PoE++ based lighting solutions. What that means is we can deliver up to 90 watts of PoE power per port from these switches. We use higher rated power supply units to provide up to 1,800 watts of PoE power budget on these switches. And we can power lighting systems and other use cases than digital buildings. As I mentioned earlier in the previous slide, we can monitor thousands and thousands of traffic flows going through these switches using IPFix and protect against security threats in the customer network. And these switches, you can connect up to 10 of these switches together into a logical switch and create a 10-member virtual chassis, providing up to 400 gig of full duplex stacking bandwidth. This is truly unsurpassed performance from these switches. We offer a number of SKU configurations. We have a 48-port fiber switch with a mix of 10 gig and 1 gig switches. We have 1 gig PoE, non-PoE in 48-port and 24-port format, as well as we have a few multi-gig options where we have a mix of 10 gig and 2.5 gig interfaces on the downlink side, as well as a 24-port multi-gig option where we have 24 ports of 10 gig. All these different hardware configurations provide flexibility to our customers to pick and choose whichever configuration that meets the requirements. All the switches offer 4x25 gig uplinks or 4x10 gig modular uplink. And as I mentioned, there are 2 dedicated 100 gig ports for stacking, which can give up to 400 gig of full stacking bandwidth. So truly differentiated hardware, high performance, flexible, ease of deployment, enabling many, many different use cases that we will get into pretty soon. Just wanted to quickly overview our campus access portfolio. On the left-hand side, we have our EX4300 series of switches, which are the fixed form factor switches, fixed power supply, fixed fans, fixed uplinks at the entry level. And then as we move up, we have the EX3400 switches, which bring in modular power, modular fans, but fixed uplinks, better performance, better scale. And then we have the EX4300, which has modular uplinks, modular power, and modular fans, higher bandwidth, higher capability, higher scale. So all these switches are shipping today for many, many years. And now today we are introducing the EX4400 line of switches, which add a quantum leap in capability on top of what we already offer in our portfolio. And on the distribution side, we have our EX4600 and EX4650, along with the QFX5120 line of switches, which are high performance aggregation switches. And to complete the portfolio, not mentioned on this slide, is the EX9200 and QFX10K, which are our core switches.
Okay. So Umang talked about all the great new switches coming out, the whole refresh of the portfolio with using the EX4400 switches. Now let's look at where do they fit into the network. We have a couple of deployment models in our portfolios. Obviously, the standalone switch, if you have a small network, a branch office, you have 1 or 2 switches deployed. Virtual chassis. We introduced virtual chassis almost 10 years back in Juniper. Probably one of the most common deployments we have seen for our customers. So the EX4400 switches perfectly fits into that architecture using virtual chassis. So we will be able to deploy the 4400 switches using up to a 10-member stack. And finally, we have the EVPN VXLAN fabric. That's another deployment models. We are seeing a lot of customers starting that deployment. We will be able to now support the EX4400 switches in all of the scenarios, standalone, virtual chassis, and EVPN VXLAN. So those are the deployment models. But let's look at the campus architecture.
So Jit, I've got a question for you.
Sure.
This one came in through Twitter from Ed Horley, and he's asking if these switches can do IPv6 only on the underlay for EVPN and VXLAN.
That's correct. We will be able to support IPv6 on the underlay for the EVPN VXLAN.
Yeah, but is it only, or do you need to do like a dual stack to get the thing to work?
We will be requiring a dual stack to do this thing, not only IPv6.
Okay.
Okay, dual stack. So talking about the campus architecture in this scenario, what we have is basically 3 different architectures or 3 different deployment models. Small, medium campus, we are talking about a couple of buildings, 3 or 4 buildings in the network, and on top of it, have about 5,000 users average. EVPN multi-homing, or we call it ESI lag, we call it collapsed core, is where we are looking at smaller deployments. The 4400 controller, the switches fits in perfectly in this scenario as a standalone switch or a virtual chassis. And then we have our campus, large campuses, could be university campuses, enterprise campuses, where we have a 3-layered network talking about core distribution and your access. 4400 switches exactly fits into the virtual chassis scenario or standalone. And in this case, you can see the EVPN VXLAN is extended between the core and the distribution. And finally, we have the IP class network. This is where we are introducing the 4400 control switches to fit into a virtual chassis or standalone environment and extend that EVPN VXLAN to the access layer. So if you are looking at extending EVPN VXLAN to the access layer, this is your platform. This is where we are looking at IP class deployment all the way to access. Let's not forget about branches. Branches comprises of a lot of our businesses. We talked about that earlier. So you can also deploy these 4400 switches and standalone branches That means small branches with a single switch, or maybe a larger branch having virtual chassis deployment on it, or multiple virtual chassis connecting through a dual WAN edge in this scenario. So 4400 is ready for deployment in all scenarios. Let it be a campus, let it be a branch solution in the network. Okay.
Thank you, Sujit. So let's talk about standards-based microsegmentation. So before we go there, let's talk about the problem that customers see in their networks today. So as we all know, there's an explosion of IoT devices that attach into any customer network. There are different types of employees, users, contractors, guest workers attached to the network along with IoT devices. It becomes a nightmare for the IT administrator to manage the network and keep it secure. They are deploying ACLs all over the place, and as devices or users move around in the network from one switch to another or one building to another, it becomes quite a challenge to maintain the network and keep it secure. So the requirement came out that we need to be able to consistently apply security policies across the network and in a granular fashion. In case there is a threat in the network, how do we block lateral threats? And the last thing was that at the same time, not only do we need to keep the network secure, we need to be able to reduce the complexity of the configuration on the switches, right? And that is where the standards-based microsegmentation comes in, which uses group-based policies. So the group-based policies, they leverage underlying VXLAN infrastructure to provide granular access policy and control. And by granular, I mean we can segment users into VLANs, but with microsegmentation, we can have different access privileges within a VLAN as well. So you are not limited to everyone mapping to a certain VLAN having the same privileges, but you can further segment it within the VLAN as well. And it's all location agnostic. So whether somebody or some device or some user is connecting to the network on switch 1 or switch 10 or switch 50 in the network, doesn't matter. You shouldn't have to go and reconfigure your network. The same set of access control policies should apply. So let's take a quick look at an example that I use. Here's a typical customer network. We have some access layer switches. At the bottom, there's some VXLAN tunnels between them. There's some distribution layer switches. There's a firewall. There's a radius server. The radius server is configured for group-based policies where different devices mapping to different VLANs, and they're assigned security group tags. And then we have various security group ACLs or firewall filters configured on the access switches, right? Let's say a DVR connects to a switch and authenticates, right? And then the radius server will push. It will detect the DVR, and it will push the security group tag associated with the DVR, which is in this case is 11, onto the switch, and the switch will store it as a metadata, right? And another camera, let's say, connects it to a different switch, or it could be the same switch, and authenticates. And in this case, the radius server assigns a security group tag of 10, noting that it's a camera, right? And then the switch will store that as a metadata. Now, if the camera tries to access a DVR, right, it will start sending its feed through the network. And on the ingress switch, we will encapsulate the traffic with the source security group tag of 10 associated with the camera into the VXLAN header as it enters the VXLAN tunnel. Right? On the egress switch, as the packets come out of the VXLAN tunnel, the egress switch will do a lookup in its local policy that it knows from the VXLAN header that the source security group tag is 10, and the destination is a DVR, which has a security group tag of 11. It looks up in its policy table and says, source security group tag of 10 and the destination group tag of 11, the policy says allow, and it will let the traffic go through in hardware. There's no control plane there, right? And conversely, if a negative scenario, if for whatever reason, a camera is trying to access another camera, right? Both of them will have the same security group tag. And in that case, when the egress switch looks at the packet, it says, sees a source security group tag of 10 and the destination security tag of 10. its policy says deny, and it will drop those packets right there. So no matter where the camera is attaching, where the DVR is attaching, where the other IoT devices are attaching, the policies, they follow those devices and users, and the switches do not have to be reconfigured. So that's the power of microsegmentation, where you can provide location agnostic, granular access control policies in a scalable manner, and you can reduce the number of ACLs that you need to configure in your network, because now you can group your devices and users according to the security group tags, and you can define your security policies according to which security group tag or users or devices mapping to which security group tag can talk to or access resources with a different security group tag, right? A number of
Can all of this, pardon the interruption, can all of this be managed through the Mist dashboard, or are there other management tools that must be used for this type of configuration?
Yeah, so there are multiple ways to manage this. This can be done on the switches itself, or we can manage it from the Mist cloud as well.
Great.
Matt, the whole point of this is part of the Mist dashboard, and you know, if you really step back and look at why microsegmentation has struggled, you know, adoption in the industry, it's not because people didn't have complex functionality for this, right? This exists in spades, but in reality, when a customer had to go in and configure this, it was hard. So you will actually see in the very next demo, a lot of this is about simplifying the deployment, and more importantly, wrapping your arms around the operations of it, right? So absolutely, our goal is that this is part of the Mist dashboard over time. Today, some of this is still in testing and beta testing as we speak. But you'll see in the demo, we've made dramatic changes in configuration, and this is going to fit into that Mist concept, Matt.
Yep. So great that somebody asked this question. I'm really glad that somebody asked this question, and good question.
So is the goal for Juniper to get like all the data center switches and the entire sort of ecosystem, as much as I hate that word, into the Mist dashboard, or is it are we going to have kind of this amalgamation of managed by CLI and managed by the cloud?
Yeah, so Brian, the goal is actually for us is very simple. In my experience, what we've seen is, for the most part, campus and branch networks, the network serving users, for us is all in the Mist dashboard. Period, end of story. Anything data center, hold your breath till Apstra comes about. Those guys have an amazing story for what Mansoor and team have built. So for data center, Apstra, for everything campus and branch, Mist, you'll hear in the next demos, we're deploying, thousands of retail stores. One of the deployments we're doing is 18,000 retail locations in 130 countries. That's where, Mist is absolutely amazing, and campus deployments as well. But that's our demarc, if that makes sense.
Now, I'd like to switch gears and talk about the rich telemetry features that are capabilities that we offer with the EX4400s. These can be broadly categorized into two buckets. So first of all, Juno's telemetry interface. We support streaming telemetry with these switches. We can monitor sensor data and CPU usage, memory usage, interface stats, PFE sensor data, PFE stats. We can stream them at pre-configured intervals out to external servers to monitor the switch of the health of the switch, right? So if anything is failing or about to fail, we can monitor them from our Mist dashboard. We can take preemptive action and keep the network up and running in a healthy condition. So the other telemetry information or feature capability that we support with the switches is, I alluded to earlier, was to examine flows passing through the switch. In hardware, it has dedicated hardware to monitor thousands and thousands of flows of customer traffic going through it, and we can define thresholds. We can define security attack signatures that it can monitor it, and if it detects there's a security threat based on the data flowing through the switch, it can send an IPFix alert packet to the management application, which can take an action, which can quarantine the port, quarantine the device, and overall increase the network security by making sure that the access or the edge of the network is secure, right? So all these switches, they support flow monitoring.
Yeah, hardware required for the flow-based telemetry, is that unique to the 4400, or is that something that we can really look forward to later? We had to replace everything.
Yeah, so the 4400 has inbuilt hardware to do the flow monitoring.
And so, Aaron, to your question, yes, it is unique to the 4400.
4400 brings the IP fix. JTI is supported on other platforms or other EX platforms, but flow-based telemetry, which is IP fix data coming, is unique to the 4400 platforms.
Now, this functionality that we're talking about, is this also going to be able to be managed through Juno Space, or is Mist dashboard meant to be kind of the single point of management for the campus?
If I haven't said it before, I'm going to say it again. All roads lead to Mist dashboard for campus and branch user-facing wired wireless WAN.
Makes sense.
Last point I wanted to touch on is dynamic port profile. Dynamic port profile, with the help of the Mist Cloud, we will now be able to configure each and every port dynamically. And in that case, we'll show you the demo of it. Depending on the device that is connecting, what information is coming from the device, it be LLDP or via radius authentication or even simple MAC addresses. Now we can convert that port where the device is connected to an access port or to a trunk port, allow the correct VLANs on it, and prune that VLANs in that trunk port. You don't have to now go in and individually configure all those devices. You can now detect what type of devices is coming onto that port and convert that port automatically. And the good part is, once that device is taken out of that port, you will convert, or we will convert that switch port to a restricted port VLAN. So as a result, somebody comes in and connects a device which is not supposed to be in the network, it will be not passing any traffic because it will be connected to a VLAN which doesn't go anywhere. So definitely dynamic profiles along with the Mist Cloud using LLDP will be a key functionality which will help customers with doing the deployments. We'll show you a live demo of that in the next section. Finally, to close out, AI-driven LAN, that's where we are focusing on, as we talked about. Sudhir mentioned about it. The EX4400 switches perfectly fits into the AI-driven LAN. So we will be able to do the ZTP of the devices and bring in those devices using those QR codes. Beautiful. They will have all the QR codes on it. And bring it into the Mist Cloud, enable Marvis and the wired assurance on top of it. We talked about Marvis earlier and also the programmable API, which is available on the Mist Cloud to do all your automation. And finally, this switch is ready for your branch and campus deployment from the Mist Cloud, as well as on existing with your other switches in the network. So that's all we have on the EX4400 launches. So very excited to introduce this. It's all live in our web pages. If you need more information, check out our web pages. It has all the data sheets on it, all the data related, and beautiful blogs written by Sudhir and team talking about the EX4400 switches.